Awe-inspiring, magnificent, and untamed, volcanoes are the rawest display of Earth's power. These titans of fire and rock, reaching skywards, are a testament to the ongoing drama beneath our feet, where forces of creation and destruction are locked in a perpetual dance. Welcome to the realm of volcanoes. Beneath our feet, the Earth is a dynamic machine. Its internal heat and pressure steadily build up, always seeking an outlet. This outlet often takes the enigmatic form of volcanoes, the visible manifestations of the turbulent dance between the inner workings of our planet and the forces that shape its surface. Over the centuries, volcanoes have fascinated, inspired, and, in some cases, terrified civilizations. In this exploration, we will delve into the geological history of these natural wonders, understand the subtle signs that precede their eruptions, and examine how the interaction between fire and rock can influence not only local landscapes, but also the global panorama. A volcano is a geological structure that allows for the release of magma, gases, and solid particles from Earth's interior to its surface. The formation of a volcano is linked to volcanic activity, a phenomenon that occurs due to the internal processes of our planet. Here's a more detailed explanation of how volcanoes are formed. The formation of a volcano begins with the accumulation of magma, a mixture of molten rocks, gases, and minerals, in a region called the magma chamber, located beneath the Earth's surface. As magma accumulates in the magma chamber, pressure increases, forcing the magma to seek an escape route towards the surface. The magma travels through channels called volcanic conduits, which can extend from the magma chamber to the Earth's surface. On the surface, the magma can be released through an opening called a crater. The shape of the crater can vary from small fissures to large volcanic calderas. There are different types of volcanoes, classified based on how they release magma and the nature of the expelled material. Examples include shield volcanoes, with their wide and gentle slopes, and stratovolcanoes, steeper and characterized by explosive eruptions. In conclusion, volcanoes are a testament to the dynamic nature of our planet. They are formed through the accumulation of magma in a chamber beneath the Earth's surface, which, under increasing pressure, seeks an escape route, resulting in the formation of a volcano. There are various types of volcanoes, each with unique characteristics and ways of releasing magma. Volcanoes, while beautiful and fascinating, are also a powerful reminder of the Earth's raw and untamed power. They serve as a window into the Earth's interior, providing us with invaluable insights into the processes that shape our world. They are a testament to the ever-changing face of our planet, a face that is as captivating as it is unpredictable.
Ever wondered what forces come together to create the fiery spectacle of a volcanic eruption? It's a complex process involving the release of magma, gases, and solid particles from Earth's interior to the surface. Let's delve into this fascinating phenomenon. Beneath the ground, there's a region known as the magma chamber, where magma, or molten rock, accumulates. This magma forms from melted minerals and dissolved gases. As magma builds up in the magma chamber, pressure rises, forcing the magma to seek an exit to the surface. The magma begins to move toward the surface through cracks or channels, known as volcanic conduits. This process is called percolation. When the magma reaches the surface, it can create openings called volcanic craters. Depending on the viscosity of the magma, the eruption can be explosive, with a large release of gases and volcanic material, or effusive, with a more peaceful emission of lava. Along with the magma, gases such as water vapor, sulfur dioxide, carbon dioxide, and others are released. The rapid release of these gases often accounts for volcanic explosions. If the eruption is effusive, lava will flow across the surface, forming layers of volcanic rock as it cools and solidifies. Explosive eruptions can produce pyroclastic material, which includes volcanic ash, pumice, and fragments of rock and volcanic glass. This can be thrown high into the atmosphere and spread across it. The eruption can have various consequences, from immediate local damage, such as destruction of vegetation and structures, to global impacts like the spread of ash in the atmosphere, which can affect climate and aviation. It's important to note that volcanic eruptions vary in intensity and characteristics, and volcanic activity can be monitored to help prevent and mitigate risks to nearby communities. The largest recorded volcanic eruption in modern history occurred in 1815 with Tambora Volcano, located on Sumbawa Island in Indonesia. This eruption is known as the Year Without a Summer or Volcanic Winter. The Tambora eruption began on April 5, 1815, and reached its peak on April 10th of the same year. The eruption was categorized as VI7, which represents a colossal eruption with global impacts. The eruption resulted in the release of massive amounts of volcanic ash, gases, and debris. The initial explosion was so powerful that approximately 150 to 180 cubic kilometers of material were ejected into the atmosphere. The event caused the death of tens of thousands of people directly due to the eruption and secondary impacts such as tsunamis and heat waves. The large amount of ash thrown into the atmosphere blocked sunlight, causing a significant reduction in global temperature. The year 1816 became known as the Year Without a Summer due to the extremely cold weather and adverse crop conditions in various parts of the world. Remember, understanding these natural phenomena not only satisfies our curiosity, but also equips us with knowledge that can help in predicting, preparing for, and mitigating the effects of future eruptions. For now, keep your curiosity alight and continue exploring the wonders of our planet.
Have you ever pondered the cataclysmic events that led to the extinction of the mighty dinosaurs? What roles did an asteroid impact and volcanic eruptions play in this mass extinction? Today we delve into this intriguing mystery, unraveling the sequence of events that culminated in a world without dinosaurs. Our story begins with a colossal asteroid or comet, which collided with Earth approximately 66 million years ago in what is now the Yucatan Peninsula in Mexico. This event, known as the Chicxulub impact, was a game-changer. The impact generated a shockwave of unimaginable magnitude, releasing energy equivalent to billions of atomic bombs. Imagine the devastation. Large-scale fires erupting, a layer of soot darkening the skies, blocking out sunlight and leading to a sudden dramatic global cooling. However, the asteroid impact was not the only catastrophic event during this period. Enter the Deccan Traps, a region in present-day India where massive volcanic eruptions were occurring. These weren't your average eruptions. They spewed vast amounts of gases, including sulfur dioxide, into the atmosphere. This further contributed to the formation of reflective particles in the atmosphere, intensifying the global cooling effect. The climatic consequences of these events were profound. The world plunged into a nuclear winter, with blocked sunlight hampering photosynthesis, leading to a mass die-off of plants. This disrupted the food chain, affecting herbivorous animals that relied on plants for sustenance and consequently their predators. Yes, including those formidable dinosaurs. The combination of the Chicxulub impact and volcanic activity created an environment incredibly hostile to life. The result was a mass extinction that significantly impacted Earth's biodiversity. The dinosaurs, the dominant creatures of that era, were wiped out, paving the way for a new geological and evolutionary era. These dramatic events marked the beginning of the Cenozoic era, where mammals began to rise as the dominant forms of life on Earth. The extinction of the dinosaurs, the rise of mammals, all were the result of a chain of events set in motion by an asteroid impact and massive volcanic activity. So, the next time you gaze up at the stars, remember the cosmic and terrestrial forces that have shaped our world. The fall of the dinosaurs and the rise of mammals is a testament to the ever-changing dynamics of life on Earth, driven by a complex interplay of astronomical and geological events.
Have you ever wondered about the ancient city of Pompeii and the cataclysmic event that sealed its fate centuries ago? Imagine a prosperous city, bustling with life, its streets echoing with the hum of daily activities, only to be silenced forever by the wrath of nature. Founded in the 6th century BC, Pompeii nestled in the Campania region of southern Italy, near the modern city of Naples. Its location by the Bay of Naples, at the foot of Mount Vesuvius, made it a thriving hub of commerce and culture. From intricately designed residences to bustling markets and theaters, Pompeii was a testament to the grandeur of Roman architecture and urban planning. Its population was a diverse tapestry of craftsmen, merchants, farmers, and nobility. The city infrastructure boasted paved streets, impressive aqueducts, and public baths. However, the prosperity and vibrancy of Pompeii were not to last. In the year 79 AD, the city faced a catastrophic event, the eruption of Mount Vesuvius. On August 24th, Vesuvius erupted explosively, raining volcanic ash and pumice on Pompeii. As the eruption intensified over subsequent days, Vesuvius spewed massive clouds of ash, rocks, and gases into the atmosphere. A deadly pyroclastic cloud, a lethal mix of hot gas and ash, raced down the slopes of the volcano. The city became shrouded in a thick layer of ash and pumice, preserving it in an extraordinary manner. This layer buried Pompeii, encapsulating buildings, artifacts, and even the bodies of victims in their original positions. The city lay forgotten under a blanket of volcanic debris. It was not until the 18th century that Pompeii was rediscovered during archaeological excavations. Since then, archaeologists have tirelessly worked to unearth the treasures and secrets of Pompeii. The excavation paints a vivid picture of Roman life at the peak of the empire. The volcanic eruption resulted in thousands of deaths in Pompeii and nearby settlements like Herculaneum. The victims, buried and preserved by the ash, create a haunting yet fascinating testament to the catastrophe. Pompeii remained buried until modern excavations, offering a unique glimpse into life in ancient Rome and the devastation caused by unpredictable natural events. Today, the archaeological site of Pompeii is a major tourist attraction, offering visitors the chance to explore the ruins and witness the remarkable remnants of one of history's most dramatic tales of destruction and preservation. To summarize, Pompeii, once a thriving Roman city, met a tragic end due to the catastrophic eruption of Mount Vesuvius. However, its rediscovery has offered invaluable insights into Roman life and culture. It stands as a powerful reminder of the impermanence of human achievements in the face of nature's might.
Imagine for a moment the world's largest volcano, Mauna Loa in Hawaii, erupting in a catastrophic scenario. What might be the potential impacts? Locally, an eruption could trigger a lava flood. Mauna Loa is a shield volcano, meaning an eruption could release large amounts of fluid lava, damaging urban areas and infrastructure. Landslides could also be triggered, especially if lava comes into contact with large bodies of water. Regionally, an explosive eruption from Mauna Loa could release vast amounts of volcanic ash into the atmosphere. This could disrupt aviation, damage structures, and cause respiratory issues in affected areas. Underwater eruptions or landslides resulting from volcanic activity could trigger tsunamis, impacting coastal areas. On a global scale, a massive release of volcanic gases, such as sulfur dioxide, could significantly impact air quality and global climate. Particles thrown into the atmosphere could reflect sunlight back into space, resulting in temporary Earth cooling, known as global dimming. In such a catastrophic scenario, evacuation of at-risk areas would be crucial. Safe shelters would also be needed to protect the population. Constant monitoring of volcanic activity is key in predicting eruptions and allowing for early evacuation and damage mitigation. Preventing volcanic eruptions is a challenge, as they are natural phenomena resulting from Earth's internal dynamics. But there are measures society can adopt to mitigate impacts and prepare for possible eruptions. Here's a summary of what humans can do. We can invest in advanced technologies to monitor volcanic activities, such as seismographs, gas meters, and satellites. This allows for early detection of eruption signs. We can develop efficient evacuation plans for risk areas, with safe shelters and alert systems that can be triggered quickly. We can educate vulnerable communities about volcanic risks, imminent eruption symptoms, and evacuation procedures. Public awareness is key to an effective response. And finally, understanding better the interactions between volcanic eruptions and climate changes is crucial to anticipate global impacts, especially concerning volcanic gas emissions. In conclusion, while we cannot prevent a volcano from erupting, we can prepare, educate, and mitigate. The key to surviving a catastrophic volcanic eruption lies not in stopping the unstoppable, but in understanding the signs, knowing the risks, and being ready to act.
Have you ever wondered about the extraordinary power of nature and how it shapes human civilization? Imagine you are walking through the cobbled streets of an ancient city, feeling the weight of history beneath your feet. The city is Pompeii, a vibrant Roman metropolis that met its untimely end in the year 79 AD when Mount Vesuvius erupted, burying the city and its inhabitants under a thick layer of volcanic ash. The tale of Pompeii is not just a story of an ancient city frozen in time. It's a stark reminder of the unpredictable might of nature and the transient nature of human existence. Yet, it also tells the tale of human resilience, of how societies can learn, adapt, and prepare for future challenges. In the face of volcanic eruptions, a comprehensive and preemptive approach is key. We cannot entirely prevent eruptions, but we can reduce the risks and minimize the adverse impacts. This approach involves three significant strategies: international cooperation, technological development, and post-eruption recovery planning. International cooperation is crucial in sharing data and resources, enabling a faster and more coordinated response in the event of volcanic eruptions that could affect multiple nations. It's about nations coming together, transcending borders, and tackling a common threat. Technological development focuses on investing in research to develop mitigation technologies, like temperature reduction methods for eruptions that can impact global climate. It's about harnessing our collective intelligence and innovation to stay a step ahead of nature's fury. Post-eruption recovery planning involves developing strategies to deal with the aftermath, including rehabilitating affected areas, supporting displaced communities, and reconstructing infrastructure. It's about building a roadmap to recovery, ensuring communities can bounce back stronger after disaster strikes. Through the silent strata of Pompeii's ruins, we are reminded of the importance of these strategies. The city's fate serves as a unique window to the past, revealing a vibrant and prosperous society, frozen in time. It's a testament to the power of nature and the ephemerality of human civilization. Yet it also stands as a symbol of human resilience, of our ability to learn, adapt, and prepare for the future. In conclusion, as we traverse the stone streets of Pompeii, we are transported back to the heart of first-century Roman life. We are invited to ponder the transience of life and the endurance of knowledge that spans centuries. The city's legacy serves as a link between eras, reminding us of the importance of understanding and preserving our history for future generations. As we marvel at the majesty of the ruins, we are moved to honor the memory of those who lived, loved, worked, and ultimately faced the tragedy that sealed their city's fate. Pompeii, a lost city, emerges as a time capsule, a lesson for humanity about the fragility of existence and the unstoppable force of nature that shapes our world. In the end, the story of Pompeii is a call to action, a reminder of the importance of international cooperation, technological development, and post-eruption recovery planning. It's a testament to the power of resilience and the importance of being prepared for the unpredictable might of nature. The lessons from Pompeii are not just for history enthusiasts. They are for all of us, a timeless reminder of our shared past, present, and future.